Have you ever wondered how long it would really take to visit every planet in our solar system? Most people think weeks, maybe a few months. But the truth, reaching some worlds would take years, others decades, and a crewed mission to the farthest planets could span generations. Space doesn't measure distance the way we do. It measures energy, alignment, and time itself. So today, we're boarding a spacecraft, and we're traveling world by world to discover just how far the solar system really is. Before we start our journey from world to world, there's a critical truth we need to understand. Space travel doesn't follow our human intuition. Distances in the solar system are not like roads on Earth. They stretch across millions and sometimes billions of kilometers. And every planet doesn't sit quietly waiting for us. Each one races around the sun at its own speed, tracing long elliptical paths in a cosmic ballet that never stops. So if we launched straight at a planet, like throwing a dart at a moving target, we'd miss every time. Spaceflight is not about pointing and firing. It's about timing, precision, and the mathematics of orbital choreography. Imagine planning a bus route where each stop moves continuously, speeding up and slowing down, dipping closer to the station, and then drifting away again. That's interplanetary travel. To reach another world, we don't chase it. We predict where it will be months, sometimes years into the future, and we launch to meet it at that point in space. This is why spacecraft follow curved trajectories called Hohmann transfer orbits. Instead of flying in a straight line, they fall into a gentle arc that intercepts the target planet. A single engine burn executed at exactly the right moment sets the spacecraft on a path that saves fuel and takes advantage of gravity. And sometimes, when the distances are extreme or fuel is precious, we borrow speed from the planets themselves. It's called a gravity assist, a maneuver where a spacecraft swings past a planet and uses its motion to slingshot forward, gaining velocity without burning propellant. It's one of the most elegant tricks in spaceflight, a quiet reminder that in the vacuum of space, knowledge is thrust. Even then, traveling through the solar system isn't just about getting there. It's also about arriving at the correct speed. Going fast is easy. Stopping is the real challenge. To orbit or land on another world, a spacecraft must slow down enough to be captured by that planet's gravity. But in space, there are no brakes, only engines. And slowing down consumes tremendous amounts of energy. That's why some missions take shortcuts, but most take the long road. Longer flight time often means dramatically lower fuel requirements. And in space exploration, fuel is life. So before we light our engines and leave Earth behind, we need to understand the rules of the journey. Plan the launch window. Aim for the future position, not the present. Use gravity instead of fighting it. Sacrifice speed to survive arrival. With that foundation in place, our voyage begins. Ahead lies a chain of worlds, scorched, frozen, storm-wrapped, ocean-hiding, and gas-giant colossi, each one teaching us something new about distance, time, atmosphere, gravity, and ourselves. Now let's make our first stop, Mercury, the smallest planet, and yet one of the hardest to reach. Our engines ignite, and Earth slowly shrinks behind us, a blue sphere fading into the eternal dark. Ahead lies the first destination in our grand tour, Mercury. It's the smallest planet in the solar system, yet reaching it is one of the greatest challenges in spaceflight, not because it's far, but because it sits too close to the sun. At first glance, Mercury feels deceptively simple. It's right there, the closest planet to us, sometimes less than 100 million kilometers away. If we could travel to the moon in just 3 days, surely Mercury shouldn't take much longer, right? But in space, intuition lies. Reaching Mercury means diving deeper into the sun's gravity well, into a region where space is not calm, but hungry. Just like it pulls planets and comets inward, the sun pulls spacecraft too. Every kilometer we descend toward the star increases velocity and demands even more energy to slow down later. Getting to Mercury quickly isn't hard. Stopping there is. Think of it like riding a bicycle downhill. Going faster takes no effort, but try to stop, and suddenly you realize just how much energy you've picked up along the way. That's the paradox of Mercury missions. Speed is easy. Survival is not. Past missions reveal the truth. Mariner 10, the first spacecraft to visit Mercury, didn't take the shortest path. It used Venus as a slingshot, bending its trajectory with precise gravitational choreography. That trip took roughly 6 months, followed by multiple flybys before diving near Mercury's orbit. Decades later, Messenger pushed the challenge even further. It left Earth, looped around our planet, swung past Venus twice, then performed 3 gravity assists at Mercury itself, before finally slowing enough to be captured in orbit. Travel time, 6.5 years. And today, Bepi Colombo, a joint ESA-JAXA mission launched in 2018, is repeating this ballet, using electric propulsion and multiple planetary assists on a journey spanning more than 7 years. Why so long? Because Mercury doesn't give second chances. Arrive too fast and you don't orbit. You fly past and fall toward the sun. To stay, you must arrive gently, with precision measured not in seconds, but in fractions of orbital velocity. And still the prize is worth the difficulty. Mercury is not a dead rock, but a time capsule, a window into the earliest era of the solar system. Its crust preserves scars of ancient impacts. Its iron core powers a magnetic field that should have faded long ago, and hints of water ice inside permanently shadowed craters suggest that even here, in this furnace world, the universe leaves surprises for those who dare to look. Imagine standing there, if such a thing were possible. The sun looms more than twice as large as it does from Earth. Temperatures swing from blistering 430 degrees Celsius, 800 degrees Fahrenheit, to frigid minus 180 degrees Celsius, minus 290 degrees Fahrenheit in the same day. A world of extremes, silent, hostile, and yet essential. Reaching Mercury is a reminder. Space does not reward shortcuts. It demands patience, planning, and humility. We've now touched the first world in our journey, the closest to the sun, and one of the hardest to tame. As we leave Mercury behind and climb outward again toward a world wrapped in clouds and mystery, our next destination rises into view: Venus, Earth's twin in size, and its mirror in fate. As we leave Mercury's scorched horizon behind, sunlight floods the spacecraft's panels once more. The next stop in our cosmic journey is Venus, Earth's sister in size and mass. Yet its perfect disguise hides a nightmare beneath the clouds. From a distance, Venus is breathtaking. It shines brighter than any other planet, glowing like a permanent sunset in Earth's sky. To the human eye, it feels gentle, romantic even, but behind that golden veil lies a world that would crush, melt, and dissolve any spacecraft that dares to land. Reaching Venus, though, is easier than reaching Mercury. Its orbit sits higher, its gravity is milder, and the sun's pull is slightly weaker. Still, no space voyage is simple. Launching to Venus means aiming for a moving target, one that swings close to Earth every 584 days during an event known as inferior conjunction. In those windows, distances drop to about 40 million kilometers, creating perfect launch opportunities. The cosmic doorways engineers wait years for. Past missions took full advantage of these alignments. In 1962, Mariner 2 became humanity's first successful encounter with another planet, taking 110 days to reach Venus. Later, the Pioneer Venus orbiter took around 198 days, and ESA's Venus Express, launched in 2005, needed 153 days to settle into orbit, proof that even a neighbor in cosmic terms is months away at best. Why go there at all? Because Venus tells a story about us. Billions of years ago, it may have looked like Earth. Oceans, clouds, a mild atmosphere. Then something went catastrophically wrong. Its greenhouse effect spiraled out of control, trapping heat, thickening the air, and turning the surface into a furnace at 465 degrees Celsius, 869 degrees Fahrenheit, hot enough to melt lead. The pressure there is 92 times Earth's, equivalent to being nearly a kilometer underwater. Even the sky rains sulfuric acid, and yet Venus keeps our scientists awake at night. Beneath the destruction lies a lesson in planetary destiny, a mirror of what could one day happen to us if we push Earth's balance too far. It's not just a world of fire, it's a warning written in clouds. We've now crossed the sun's inner neighborhood, Mercury and Venus, two extremes of survival. But as we leave the brightness behind and set course for the red horizon ahead, our next destination calls with a different question altogether. Mars. Not just how long to get there, but who will go first. Beyond the burning skies of Venus lies a quieter world, a rust-colored desert bathed in thin sunlight, orbiting farther from the warmth of the sun. Mars, the red planet, a place where science, imagination, and ambition converge. From Earth, Mars appears almost within reach, sometimes shining brighter than any star, sometimes fading to a dim ember, lost among the constellations. But appearances deceive. Depending on their orbits, Earth and Mars can be as close as 56 million kilometers or as far apart as 400 million. And that single difference can change everything, from travel time to fuel requirements to the very survival of a mission. For engineers, Mars is a game of timing. Every 26 months, a narrow launch window opens, a moment when both planets align just right, allowing for the most efficient trajectory known as a Hohmann transfer orbit. Miss that window, and you wait another 2 years. Catch it, and your spacecraft rides the gentle curve of gravity from one orbit to the next, like a stone skipping across a cosmic pond. Even with perfect timing, Mars is still a marathon. Typical missions, like NASA's Curiosity, Perseverance, and InSight, spend 7 to 9 months in transit. That's hundreds of millions of kilometers in silent travel propelled by nothing but inertia and sunlight. And that's just for robotic explorers. For humans, the story is far more complex. A one-way trip to Mars isn't measured only in distance, it's measured in risk. Radiation, isolation, psychological stress, limited supplies, and the constant exposure to solar storms. Every factor turns the journey into a high-stakes experiment in survival. Engineers estimate that a crewed mission, even with advanced propulsion, would still require 6 to 9 months outbound, plus another 18 to 24 months waiting for the return window to open. Round trip? Close to 3 years in deep space. And yet, we're closer than ever to making it real. NASA's Artemis program is laying the groundwork, building the launch systems, habitats, and in-space infrastructure that could one day push beyond the moon. Meanwhile, SpaceX's Starship promises something more audacious: rapid, reusable transport to another world. If its design succeeds, high-thrust Raptor engines, stainless steel shielding, and in-orbit refueling, it could bring Mars within reach for the first time in human history. Still, there's a reason every probe and rover before us moved one step at a time. Mars demands patience. It is a planet of promises and paradoxes. Its valleys hint at ancient rivers. Its polar caps glisten with frozen water, and its thin, ghostly atmosphere whispers stories of a time when life might have thrived. Reaching Mars is not just about exploration, it's about perspective. Each mission teaches us how fragile and rare Earth's stability really is. Curiosity showed us that Mars once had flowing water and complex chemistry. Perseverance is now searching for the fossil fingerprints of ancient microbes. And orbiters like MAVEN have revealed how Mars lost its protective atmosphere, stripped away by the solar wind over billions of years. A warning, written in red dust, of what happens when a world loses its shield. For now, robotic eyes do the watching, but one day, real human eyes will see the Martian horizon. They'll stand beneath a salmon-colored sky, where the sun looks half the size it does from Earth. They'll see Olympus Mons, the tallest volcano in the solar system, towering 26 kilometers high. And they'll feel gravity just 38% of what they're used to. A single step will feel lighter, but the distance home will weigh heavier than ever before. Reaching Mars is more than a technological triumph. It's a mirror held up to our species, proof that curiosity, persistence, and courage can carry us across the void. Because Mars isn't just a destination, it's the beginning of something far larger, the first bridge between worlds. And as we leave its crimson plains behind, our engines once again awaken. The inner solar system fades into a pale glow. Ahead lies a vast ocean of darkness, and the largest planet we've ever known, a giant of storms, radiation, and moons that may hold life beneath their icy shells. Beyond the red deserts of Mars, sunlight begins to fade. Our spacecraft now drifts through the asteroid belt, a vast graveyard of stone and metal left over from the solar system's birth. And ahead, in the dim golden glow, a colossal world begins to rise. Jupiter, a gas giant so massive that it could fit more than 1,000 Earths inside, and yet it's made mostly of hydrogen and helium, the same ingredients that built the stars. From a distance, Jupiter looks calm, striped in shades of beige and amber. But up close, it's chaos incarnate. Superstorms larger than planets, lightning bolts 1,000 times stronger than anything on Earth, and winds that never stop. The Great Red Spot, that eternal storm, has been raging for at least 4 centuries, maybe longer. To reach Jupiter isn't just to visit another planet. It's to stare into a living engine of weather, magnetism, and energy so vast it shapes the orbits of entire moons. It took Pioneer nearly 640 days to reach it. Voyager 1, flying through perfect alignment, made the journey in about 21 months. But like Mercury, the difficulty isn't just getting there, it's slowing down enough to stay. When NASA's Galileo finally entered orbit after almost 6 years of travel, it revealed that Jupiter is more than a planet. It's a miniature solar system with over 90 moons, some larger than Mercury itself. Among them, Europa, a frozen world with an ocean beneath its crust. If life exists beyond Earth, Europa might be where it hides, in the dark, in the deep, warmed not by sunlight, but by gravity's slow and endless pull. From there, our voyage continues outward to Saturn, the planet of rings, of light and shadow. Cassini, the most ambitious mission ever sent there, traveled for 7 years to arrive at just the right speed, and then spent 13 years writing Saturn's epic in data and light. Through its eyes, we saw Titan's methane seas, Enceladus's icy geysers, and the ghostly beauty of rings that stretch hundreds of thousands of kilometers, yet are thinner than a sheet of paper. Farther still lie Uranus and Neptune, distant giants bathed in cold blue hues. Only Voyager 2 has ever reached them, taking 8 and 12 years respectively. Since then, no spacecraft has returned. Their mysteries remain suspended in the dark: tilted axes, wild winds, hidden oceans, and atmospheres that glow in colors science still can't fully explain. And then, at the edge of it all, Pluto. A dwarf planet, yes, but also the last great chapter of human curiosity. It took New Horizons 9.5 years to reach it, traveling at 16 kilometers per second, faster than any object we've ever built. When it finally arrived, it revealed a heart-shaped plain of frozen nitrogen, a symbol carved in ice at the end of the solar system's road. We've now crossed more than 4.5 billion kilometers of cosmic distance, and yet, this journey, from Mercury to Neptune, isn't really about distance at all. It's about perspective. Every planet, every orbit, every decade spent chasing the unknown reminds us that space is not empty. It's alive, in motion, in mystery, in endless beauty. So the next time you look up at the night sky, remember, those tiny points of light aren't just far away. They are destinations, each one waiting for us to arrive. If you enjoyed this journey across the solar system, make sure to leave a like, share it with another explorer, and subscribe to Stellar Path, because the universe isn't just something we observe, it's something we're learning to cross, one world at a time.